Hi, I'm going to go through a simple guide to fiber channel zoning. This is really for people who are looking to deploy Azure Local, and they currently run on iSCSI. And Azure Local now has the ability to add SAN, but it's limited to fiber channel. And I want to go over some of the ways that we can make fiber channel very approachable to be able to deploy with Azure Local. A lot of people think of fiber channel and they think, oh, that's a complex storage thing. It's really not. It's a very simplified network for storage. And we're going to go over some of the differences. One of the big differences is when you deploy iSCSI as your choice of SAN, you have a lot of different options and you can intermix everything. You can hook 100 gig switches up, you can have 40 gig uplinks, 10 gig uplinks, 25 gig. You can use all the different speeds you want. Fiber channel is a little bit more controlled in the sense that you can run 64 gig speeds or 32 or 16, and they always support 2 back. So if you buy 64 gig switches, they'll support 64, 32, and 16. If you buy 32 gig switches, it'll go all the way back to 8. So the idea is you can future-proof yourself and, for instance, deploy 64 gig switches, even though the array right now only has 32 gig ports. But at the same time, you can also save money and just deploy 32 gig infrastructure all the way across. I should also note that there's some differences in how you network them. Commonly, when people deploy iSCSI, they use commodity switches. They use, heavily interconnected and gateway switches, and they carve out a section for iSCSI. Whereas with Fibre Channel, you are using dedicated storage-only switches. And you're going to find that they get deployed in a very different way. It's usually a very flat network. It's usually an isolated network. It's a non-routed network. You almost never go more than 2 hops. So it's a very tight network that's designed to be very, very redundant. It's very storage-centric. It's dedicated hardware. It's very rarely deployed in shared infrastructure. Now, the fan-out ratios are different too. Most people, when they look at Ethernet, they think of fan-out ratio of about 14 to 1, between 14 to 1 and 7 to 1. So you may have 7 hosts connected with 10 gig E, but your uplink may only have one 10 gig uplink. In Fibre Channel, that's the bare minimum. You almost want to go down to 4 to 1 or 3 to 1 for your fan-out ratio. And that's much easier to do in Fibre Channel world. I'm going to show you what that looks like. Partially, the reason that's easier to do is because of the way they do their actual their actual load balancing and their trunking. So when you connect multiple ports between 2 Fibre Channel switches, they will automatically ISL trunk them, and they'll automatically load balance across them. So you're not going to have this problem where when you hook switches up, you have to actually build trunks, build flow control. You've got to do a lot of that stuff manually on a Fibre Channel, or on an Ethernet switch. And in Fibre Channel, it natively knows how to trunk everything, and it natively knows how to load balance on a frame basis. Instead of using a source destination hash, you can find ISLs in an Ethernet world get more heavily hit, whereas ISLs in a Fibre Channel world usually load up equally. Also, in a Fibre Channel world, the protocol has built-in buffer-to-buffer credits, meaning it's impossible to have congestion because you cannot have, well, you can have congestion, but you can't have collisions because the protocol is actually designed, in fact, a lot of people don't realize this, from the old days of token ring where you had to have a token to talk. That's what a buffer-to-buffer credit is. It's a token that allows you to talk on the network. So it's impossible to have congestion, or I should say collisions, because you have to have the token to be able to send and receive things. In Ethernet, it's a little different. In Ethernet, they rely on data center bridging, on flow control, on sending pause frames. There's other ways they accomplish that same thing. Both Fibre Channel, you limit the hops, you keep it flat, you keep it tight, and you keep it really, really close, and then you have this buffer-to-buffer credit system that prevents starvation. Also, a lot of people look at it and see security as an issue. In Fibre Channel, you have native security because it's not necessarily a discoverable or a routable or even a broadcastable network. You can't get on a Fibre Channel switch and be able to jump from server to server to server. You're stuck on that switch. Ethernet, it's a little different story. Just because you're running iSCSI on it doesn't mean you can't also run all the other things you can run. Now I'm going to show you examples of what these fabrics look like and how different they are. Now, when you deploy a storage network, it's different than Ethernet in the sense that if you lose Ethernet connectivity between your server and your clients, okay, the website may be down, but you don't actually see problems. When you lose your storage access, you can blue screen your servers. You can do all kinds of bad things to your servers. So we want to make sure that storage network is really redundant. To do that, we usually do a red and a blue fabric. We have two independent fabrics, and there are no ISLs between those switches. The red fabric and the blue fabric are complete independent fabrics of their own. They have their own switching, their own configuration, their own everything. And the idea is every server is going to connect into the red and the blue fabrics, and every storage device will have multiple connections into the red and the blue fabrics. So with that said, let's show you how your fabrics grow. There's three kinds of fabrics that grow out there. There's single switch, which nowadays you can get 64 ports on a single switch pretty economically. So up to about 60 ports is where you want to go with single switch. It's really good for entry level. It's also good for Azure Local. You can go to, and what that looks like is that you simply have a red fabric that's a single switch and you connect everything to it. Very, very simple. You can also do ports on demand. So you can buy a 24-port switch that only has 8 ports available that are active, and it keeps the price of that switch very, very low. And at a future date, you can purchase those extra licenses for those extra ports. Now, you can go from that to a small fabric where you might have 2 or 3 switches connected using interswitch links. And remember, once you plug these interswitch links in, they automatically do their thing, and you now have a fabric of that many ports. But the idea here is that now between switches on a 2-switch fabric or a 3-switch fabric, it's very easy to do this. And again, you can get a lot of ports here. You can go between 64 ports up to hundreds of ports, many hundreds of ports that are available to you here. The next stage is core edge, where you actually want to do a core switch with a bunch of edge switches. Now I should note, the red and the blue fabrics will have their own core edge switches. You do not intermix them. So this is just showing the red side. You'll duplicate this on the other side. Now either you can deploy a single core with a bunch of edge switches, which is less common than if you run dual core. And the reason is if that core switch were to fail, you'd have a whole bunch of edge devices that are now islands that can't talk through, and you'd have to use the alternate switch, which means the blue fabric would get very heavily hit. On the other hand, if you run dual core switches, if you have a server connected to switch 1 on the edge, and it needs to talk to storage on switch 6 on the edge, it will load balance its traffic across all 4 of the black ports and all 4 of the white ports using both cores equally. So both cores will get loaded at the same time. And again, these cores don't have to be that big, so you can actually have smaller cores. You can also replace core switches without incurring downtime of one of your fabrics. Remember that if I need to, I can also grow organically. I can start out with a single core switch in a red fabric with maybe 2 or 3 or 4 edge switches. And at a certain point, I may start growing to the point where I need to actually add more and more ports. I can put another core switch in and start moving cables around. The ISLs will figure it all out for me. So you can organically grow from a single core to a multi-core. You can organically grow from a single switch to a small fabric. You can even grow from a small fabric to a core edge with a little bit of planning. So again, these fabrics can get very, very large, but they're not the same scale as an Ethernet fabric. Once you get to 500 or 1,000 devices on a Fibre Channel Fabric, you're really looking at islands at that point. With Ethernet, you can go far beyond that. Now, with that said, let's talk about zoning, because we've talked about fabrics and how easy it is to set up ISLs instead of trunks. Let's talk about how to zone them, because you don't want every server seeing every other server. In fact, we isolate servers much more drastically than we would in an Ethernet concept. So the idea is you have 3 different kinds of zoning. You can either do port zoning. Now, port zoning is where you actually specify which switch by domain ID and which port is allowed to see others. By worldwide name zoning, you actually say which worldwide names are allowed to see other worldwide names, or you can do a combination of the two. Don't recommend the combination because it's not enforced by hardware. If you do the other two, they're actually pushed into hardware, and it actually is done at a port level. So port zoning can be very, very simple because all you have to know is your domain ID of your switch. Let's say you have switch number 3 and it has port 14. That's a very easy concept to learn. Port 14 goes to server 3, HPA 1. What it does, though, is it requires that you have a map of exactly what servers connect to what port on what switch. And the same with targets. You need to be able to map all that out end to end and know all that. Now, I prefer worldwide name zoning. And the reason I prefer worldwide name zoning is because it has a much looser relationship between the servers and storage's physical ports and where they're connected to the fabric. It's more suitable when you physically aren't there on the data center floor working, because I can do all my worldwide name zoning simply by logging into my switch and my servers and retrieving my worldwide names. And then I simply tell my on-site staff that this server should connect one port to one fabric, one port to the other fabric, and at that point I don't care. Or I can say, connect up my target array and hook the following ports up to the A fabric and the following ports up to the B fabric, and I don't care what switch ports you put them on, just get them all in there. Now, I'm oversimplifying it to some extent, but the point is I only need to learn about the worldwide names. And I'm going to show you what these look like and how these actual commands run. Now, I should note that if you do port zoning and an HPA fails and you replace the HPA, as long as you hook up the same cable to the same location, you don't require any zone updates after that. It'll just continue to work. However, if a port fails on the switch and you have to move a server from one port to another, you will have to make a zone change. On worldwide name zoning, on the other hand, if an HPA were to fail and I have to remove the HPA and put a new one in, it's going to have a new worldwide name, so I have to update the zoning. But if a physical port fails on a switch, I can move that port to another location and the server will continue to operate. Now, I should also note, if you organically want to grow from a single fabric to multi-fabric, or from multi-fabric to core edge, or a single fabric, single switch to multi-switch to core edge, then organically that's easier to do with worldwide name zoning because your port domain IDs may change when you start hooking switches together. So going from a 3-switch fabric to a core edge fabric would require that you rezone everything, because all of your port IDs are going to change. Well, all of your domain IDs will change. Now, I should also note that if I have both worldwide names for a host in my alias for that host, and that exists on both switches, that it doesn't matter if I get my ports backwards. So, for instance, if I were to plug port 0 into the red fabric, and then service it, and then plug port 1 into the red fabric, it would still continue to work because the zoning would still be there as long as I use both worldwide names in both locations. Now, let me show you what the commands look like for this. So to create an alias, I want to name my alias after my host name plus a suffix. And the reason for that is because you can't have a host name, or I'm sorry, you can't have an alias in a zone with the exact same name. So for instance, if I have an Azure Local node, I have Azure Local Node 1. I want to call that alias Azure Local Node 1 HPA. If I have my HPE MP B10000 and I want to use, let's say, node 0 slot 3 port 1, I could put HPE EMP B10K N1 S3 P0, for instance. Or I could call HPE MP B10K all, and I could actually put all the worldwide names for that array. And at that point, whenever I use that alias, it would automatically bring in all those names. So again, I can use all or I can use individuals. If I use all, I can only ever expose a alias. I can only ever expose a host to all of the ports at once. I can't have the granularity of saying, I want these servers to see this port and these servers only to see these ports. So it depends on your needs here. If you were to split one B10000 among 4 Azure Local clusters, you might want to separate those out or you might not. Now, if implementing single initiator zoning, which is the standard in the industry, you should have a zone for every host you have. This will make it so that no host can ever talk to another host. the switch will simply not allow it. So what you do is you create a zone with the same NetBIOS name as your server, and the only thing you put in that zone is the alias for its HPAs, which is, let's say your machine's called Azure Local Node 1. So you make a zone called Azure Local Node 1, and inside of it, it will have an alias called Azure Local Node 1 HPA, and it will have another alias called HPE MPB10K all. And then you save that zone. Once you save that zone, you now can see those two things can now see each other. Now, once you have the zone created, you have to add it to a running configuration. So there are three configurations on the switch. There's the running config, there's the config that you're working on in memory that's not currently running, and then there's the actual saved config. On reboot, the saved one's the one that gets loaded up. So you can look at the running config simply with saying config show. You can create or add to the running config a few things, and it will be done in memory, but it isn't done on the switch yet. So you can queue up hundreds of changes, and then as soon as you enable the config, the in-memory config becomes the running config, and you're immediately up and running. If you're happy with it, you then save. The zoning commands look like this. So again, we've talked about how to do it or why to do it. Here's how to do it. So I run ali create, my host name, and the items. So in this case, I would do my worldwide port name number 1, my worldwide port name number 2, and I'd be done. I wouldn't have a third item, obviously. But if it was ali create my target array name underscore all, and I could have the worldwide names for all of my ports there. And again, worldwide port names look like this. Your numbers will be different, but it's a series of numbers, hexadecimal numbers separated by colons. And simply to put multiples in here, you put semicolons between them, so you have multiples here. Now that's the exact same process to create a zone, because an alias doesn't do anything. An alias is just an easy way for you to monitor things. To create a zone, you simply say zone create, you give it a host name, because remember, every zone is going to map back to a host, and then you add all the aliases you want to add in there. Alias 1 would be your host name HPA. Alias 2 might be your targets. Alias 3 could be a completely different array. But only one of these aliases should ever be another initiator. Or I should say another set of initiators like another host. And then once you've got the zone created, you need to add the zone to the currently running configuration. If you don't know what the currently running configuration is, you can do config show, CFG show, and it will show you a list of the running configuration and the memory configuration. And once you've got that name, the config name, you can say, if there's no config, you can create one. Say config create, config name, and you add all the zones you want to add and hit enter. Now remember, you're just doing it in memory. You haven't actually made it happen to the switch yet. Or you could simply add to the running config the zones, but again, you're doing it in memory only. Now, when you want to enable it, let's say you got hours and hours of work and you got all these zones set up the way you want them, but your service window doesn't start until midnight. So you log back in at midnight, then you kick off the config enable. And a few seconds later, all of your zone changes, or all of your zones now become active and they're all operating. So the idea here is that config enable is the thing that makes it happen in the real world. Until that, nothing actually happens on the switch. Now, if you like everything you see, you can simply say config save. And it will save that config, so the next time the switch reboots, it'll automatically boot it back up in the correct way. If you forget to do config save, if that switch were to ever reboot, it would default to whatever the last saved config was, which might not include your changes. So again, the zoning is actually very, very simple. Creating ISL links is very, very simple. Zoning is the thing that people are afraid of the most, and it's actually the simplest thing you can do. Please contact me if you have any questions about zoning on switches, or if you have questions about how to do inter-switch links, if you have questions about the kinds of switches you can deploy, how to grow from one fabric to the other, how to build your red and blue fabrics. And again, I call them red and blue. Those are just my terms. You can use A fabric, B fabric. Again, Fibre Channel is not that scary of a thing to adopt. It's very, very user-friendly, and it's very hard to mess up. So it's a highly reliable network. Thank you very much for your time. Appreciate it.